എല്ലാവർക്കും ലൂക്കയുടെ ആര്യഭട്ട 50 ടോക്കിലേക്ക് സ്വാഗതം. ഇന്നത്തേക്ക് 1975 ഏപ്രിൽ 19 ഇന്ത്യയുടെ ആദ്യത്തെ ഉപഗ്രഹമായ ആര്യഭട്ടയുടെ വിക്ഷേപണത്തിന്റെ 50-ാം വാർഷികമാണ് ഇന്ന്, വാർഷിക ദിനമാണെന്ന്. അപ്പോ നമ്മൾ വിപുലമായ വിവിധ പരിപാടികൾ ലൂക്കയിൽ ആലോചിച്ചിട്ടുണ്ട്. ഇന്നലെ നമ്മൾ ആര്യഭട്ടയുടെ ഭാഗമായിട്ടുള്ള ചന്ദ്രമോഹൻ സാറുടെ ടോക്ക് ഉണ്ടായിരുന്നു. ഇന്ന് സിദ്ധാർത്ഥൻ സാറുടെ ആര്യഭട്ട വിക്ഷേപണത്തിന് ശേഷമുള്ള ഇന്ത്യയുടെ 50 വർഷത്തെ ഉപഗ്രഹ സാങ്കേതിക വിദ്യയുടെ ചരിത്രം വിശദമാക്കുന്ന ടോക്കാണുള്ളത്. അപ്പോൾ ഇന്നത്തെ ടോക്കിലേക്ക് എല്ലാവർക്കും സ്വാഗതം. നമ്മളിത് കഴിഞ്ഞ് ഒരു സ്കൂൾ വിദ്യാർത്ഥികൾക്ക് വേണ്ടിയിട്ട് ഒരു ആര്യഭട്ട ക്വിസ് ലൂക്ക ക്വിസ് സൈറ്റിൽ പബ്ലിഷ് ചെയ്യുന്നുണ്ട്. കൂടാതെ ആര്യഭട്ട മോഡൽ നിർമ്മാണത്തിന്റെ ഒരു മത്സരം നമ്മൾ വെക്കുന്നുണ്ട്. അത് ഈ ആഴ്ചകളിലായിട്ട് നമ്മൾ പബ്ലിഷ് ചെയ്യും. അപ്പോൾ അത്തരം മറ്റു പരിപാടികളും കൂടി നടക്കുന്നുണ്ട്. കൂടാതെ ആര്യഭട്ടയുമായി ബന്ധപ്പെട്ട ചില ലേഖനങ്ങളും ലൂക്കയിൽ പ്രസിദ്ധീകരിക്കുന്നുണ്ട്. അപ്പോൾ ഇന്നത്തെ ടോക്കിലേക്ക് എല്ലാവരെയും സ്വാഗതം ചെയ്യുകയാണ്. ഇന്ന് നമുക്ക് അവതരണം നടത്തുന്നത് സിദ്ധാർത്ഥൻ സാറാണ്. ലൂക്കയുടെ എഡിറ്റോറിയൽ ബോർഡ് അംഗമാണ്. ഐ.എസ്.ആർ.ഒ.യിലെ റിട്ടയർഡ് ശാസ്ത്രജ്ഞനാണ്. ഡിജിറ്റൽ സിഗ്നൽ പ്രോസസിംഗ്, സാറ്റലൈറ്റ് കമ്മ്യൂണിക്കേഷൻ മേഖലയിലാണ് സാറിന്റെ വൈദഗ്ധ്യം. ധാരാളം പുസ്തകങ്ങൾ പരിഷത്തിന് വേണ്ടിയും മറ്റ് മലയാളത്തിലെ മറ്റ് പ്രസാധകരിൽ നിന്നൊക്കെ സാറിന്റെ പുസ്തകങ്ങളുണ്ട്. ഒരുപക്ഷെ പറക്കലിന്റെ കഥ എന്ന് പറഞ്ഞ ആദ്യ പുസ്തകം മുതൽ പാൽനക്ഷത്രങ്ങളുടെ മായിക ലോകം, ബഹിരാകാശ ടൂറിസം, സ്റ്റീഫൻ ഹോക്കിങ്ങിനെ കുറിച്ചുള്ള പുസ്തകം, നമ്മുടെ സൗരയൂഥം, ബഹിരാകാശ പര്യവേഷണത്തെ സംബന്ധിച്ചുള്ള വലിയൊരു പുസ്തകം പരിഷത്ത് ഇറക്കിയിട്ടുണ്ട്. അദ്ദേഹത്തിന്റെ അതിരുകളില്ലാത്ത ബഹിരാകാശം, ഒത്തിരി പുസ്തകങ്ങൾ ശാസ്ത്ര സാഹിത്യ മേഖലയിൽ സാറിൻ്റെതായിട്ടുണ്ട്. കൂടാതെ ഇംഗ്ലീഷിലും മിസ്റ്റീരിയസ് വേൾഡ് ഓഫ് കോമറ്റ്സ് എന്ന് പറഞ്ഞൊരു പുസ്തകമുണ്ട്. സാറെ സ്നേഹപൂർവ്വം ഇന്നത്തെ ടോക്കിലേക്ക് സ്വാഗതം ചെയ്യുകയാണ്. ബഹിരാകാശവുമായി ബന്ധപ്പെട്ട് ലൂക്കയില്, നമ്മുടെ സ്കൂൾ അറ്റ് ലൂക്കയില് സാറിന്റെ ഒരു ലേഖന പരമ്പര വരുന്നുണ്ട്. കൂടാതെ ലൂക്കയിൽ സ്ഥിരമായിട്ട് സാറിന്റെ ഒരു പങ്ക്തി ഇപ്പൊ പ്രസിദ്ധീകരിച്ച് തുടങ്ങിയിട്ടുണ്ട്, സയൻസ് വാച്ച് എന്നുള്ള പേരിൽ. അപ്പോ സാറിന്റെ ലൂക്കയുടെ ഭാഗമാണ്, ലൂക്ക എഡിറ്റോറിയൽ ബോർഡ് അംഗമാണ്. സാറിനെ പ്രത്യേകമായിട്ട് ഇന്നത്തെ പരിപാടിയിലേക്ക് സ്വാഗതം ചെയ്യുന്നു. ഇന്ന് നമ്മളൊരു 7:30 ഇപ്പോ 8:30 വരെയുള്ള ഒരു അവതരണം, അതിനുശേഷം നമുക്ക് അതുമായി ബന്ധപ്പെട്ട ചർച്ചയും ആവാം. അപ്പോൾ നമുക്ക് തുടങ്ങാം.
ഓക്കെ, താങ്ക്സ് റിസ്വാൻ. ഇവിടെ എൻ്റെ സാക്ക് എന്നുള്ള ധാരാളം സുഹൃത്തുക്കൾ, ഐ.എസ്.ആർ എന്നുള്ള സുഹൃത്തുക്കൾ നോൺ മലയാളം സംസാരിക്കാൻ അറിയാത്തവർ കൂടി ഉണ്ടെന്ന് എനിക്കറിയാം. അതുകൊണ്ടൊരു മിക്സ്ഡ് മോഡിൽ സംസാരിക്കാമെന്നാണ് ഞാൻ കരുതുന്നത്. വെൽക്കം ടു ആൾ മൈ ഫ്രണ്ട്സ്. I can see many of you who are from ISRO, SAC and other centers who cannot follow Malayalam fully are also has joined today's talk. So I hope I'll make a mixed language presentation, but it will be mainly in Malayalam because LUCA and KSSP are dedicated for spreading science among the Keralites, the Malayalam speaking children, teachers and the general public. So pardon me. So let me go to the presentation. This is the second talk. Yesterday, another person from the original Aryabhatta team, Chandrasekhar, spoke on the detailed design aspects and other things of Aryabhatta. I'm not going through such a deep talk, especially because I know my audience. They are college students and school students, teachers. So I don't think there is any need for a what you call deep coverage. Rather, I'll be covering ISRO's achievements in the last 50 years, starting with Aryabhatta and ending with the SpaceX. So let's go to the class. I'll make a small presentation. I'll be switching off my camera because you can see, I think I'm appearing with a little wavy. So we are going to have a quick travel through 50 years of Indian satellite technology. Just because I have added technology, please don't mean that I'll be covering the details of each and every aspect. The Indian space program greatly differs from other spacefaring and using country. Okay, ഇന്ത്യയുടെ സ്പേസ് പ്രോഗ്രാം മറ്റ് ബഹിരാകാശ രാജ്യത്തിൽ പ്രവർത്തിക്കുകയോ അതിൽ ബഹിരാകാശ യാത്ര ചെയ്യുന്നതുമായ രാജ്യങ്ങളിൽ നിന്ന് അവരുടെയൊക്കെ പാത ആദ്യം ബേസിക്കലി മിസൈലിന് വേണ്ടി റോക്കറ്റുകൾ ഉണ്ടാക്കുകയും പിന്നീട് വളരെ എക്സാമ്പിൾ വാനലൈറ്റ് പ്രോബ് മാതിരിയുള്ള വളരെ ചെറിയ സാറ്റലൈറ്റുകൾ ഉണ്ടാക്കുകയും പിന്നീട് ഓഫ്കോഴ്സ് ആ സാറ്റലൈറ്റുകൾ വലുതായി ആൻഡ് പിന്നീട് ആപ്ലിക്കേഷൻ ഏരിയയിലേക്ക് മൂവ് ചെയ്യുന്നുണ്ട്. പക്ഷെ നമ്മുടെ ഭാഗത്ത് നമ്മൾ സൈമൾട്ടേനിയസ്ലി ആപ്ലിക്കേഷൻസ്, സാറ്റലൈറ്റ് ഡിസൈൻ ആൻഡ് ഫാബ്രിക്കേഷൻ ആൻഡ് ലോഞ്ച് വെഹിക്കിൾ ഡിസൈൻ ആൻഡ് ഡെവലപ്മെന്റ് ഇതൊക്കെ കൂടി നമ്മൾ ഒന്നിച്ചാണ് ചെയ്തത്. സോ വി ഹാഡ് സൈറ്റ് ഇൻ 1974, Aryabhatta in 1975, Bhaskara 1 and 2 later. We have the first communication satellite, Apple in 1981, followed and simultaneously in Trivandrum, they were developing the satellite launch vehicle, augmented satellite launch vehicle, and the polar satellite launch vehicle later. Perhaps the best thing happened to ISRO is we had very high visionary leadership. Dr. Vikram Sarabhai, Dr. Satish Dhawan, Brahma Prakash, Professor Yashpal, and many others. Their dedication, their attitude, their management, and everything might have helped ISRO to rise above many other research establishments within India. Here is Dr. Vikram Sarabhai, and on the other side is Dr. Satish Dhawan. If you talk about Indian space program, we have to go back to 1963 when Sarabhai, Brahma Prakash and others team started launching sounding rockets from Tumba. Tumba Equatorial Rocket Launching Station, TERS, that is the full name. Tumba was a fishing village in down south in Kerala, in Trivandrum district. So our space program was born there. Especially, space program was born in a church. That may look very contradictory nowadays, because one is absolutely science and the other is spiritualism. Still, there was an amicable relation between the church-going people, the fishermen who lived in Tumba village, the Kerala government, all our science team and everybody. Perhaps it is that unity, that feeling that we should put our might together for our country, which might have taken ISRO to great heights. Then comes the 1974 Satellite Instructional Television Experiment, or SITE. Why I am going back to these things, SITE as well as the Tumba, is because many other countries like USSR or USA started directly from missile development. But the Indian program truly started with sounding rocket launch and SITE program, the epicenter of which was Space Application Center, Ahmedabad, where I worked, and many of our colleagues who are in today's meeting also worked. Now, interesting thing is, perhaps the SITE spread over nearly how many villages we will see in the next slide, brought not only the application of satellite to these remote villages of India, but even the television sets. Perhaps they might have seen the television for the first time. SITE was a program spread over Rajasthan and Madhya Pradesh, north of Bihar, Madhya Pradesh, and the east side Orissa, Karnataka and Andhra, covering 2,400 villages in 20 districts of 6 Indian states. Through this, ISRO took the initiative to educate the people on emancipation, women's emancipation, health, need of education, all such aspects. This is a photograph published by Times of India at that time. The comment was, "Star Trek on a shoestring," perhaps they meant budget. SITE, pioneered by ISRO, till date remains one of the largest such experiments by any country. That is why the United Nations awarded the Marconi Prize to Professor Yashpal, who was then the director of SAC. We come to Aryabhatta. Aryabhatta was fabricated in the industrial sheds of Peenya, a suburb of Bangalore. And as a gist, it cost 5 crore Indian rupees of that time. It was 360 kg mass or weight. The USSR gave us solar panels, nickel carbide battery, and spin stabilization mechanism free of cost, and they launched also free of cost. That is what yesterday Chandrasekhar's talk clarified. And original plan was to launch it from US using a Scout rocket. It was also a 3-stage rocket, if I recall. But then there was, because of the Pokhran one, there was a US embargo, and US was a bit cold shoulder to India's ideas of going into rocket launching, satellite launching, and other thing. So finally, it was launched from Kapustin Yar near Volgograd on 18th April 1975. It was a near circular orbit, 563 kilometers perigee and 619 apogee. Apogee is in an orbit, the farthest point from Earth, and perigee is the nearest point to Earth. We can say it's near Earth, but Bhaskara 1 and 2 had better near circular orbits. Inclination was 7 degrees, and I think the reason was it was launched from Kapustin Yar. The latitude of Kapustin Yar is 48 degrees north, subtraction north, and this is tied to that. That's what I believe. Now, making Aryabhatta was a real saga, because it was in the 1970s. Professor U.R. Rao has come back from US, leaving a lucrative academic job to shoulder the responsibility of satellite imaging. Nowadays, we talk about the Indians going and heading Google and Microsoft and this and that, really running away from the country. Rather, Professor Rao and many others came back at the request of Vikram Sarabhai and Jawaharlal Nehru, the then Prime Minister, or at that time it was Indira Gandhi, and they returned to help the country. R.O.യ has written a beautiful autobiography. I don't recall the name. It was something like My Personal and Official History of ISRO or something like that. He left DAE, Department of Atomic Energy, which was established by that time. While the space program was uncertain whether it will get really take off or not. But R.O.യ and many others left their job to join the so-called uncertain space program. They worked and tested the Aryabhatta satellite in the industrial shells of Peenya near Bangalore. Peenya used to be muddy during the rains and hot during the summer. So one of the very young scientists at that team, at the time in the Aryabhatta team, yesterday he was in the meeting, I don't know whether he's there today. He wrote a good article in Indian Academy of Sciences magazine, which describes how difficult it was to work in that industrial sheds at that time. Those in the fledgling space program were also worried about the budget. There are some mistakes which in the spelling mistake there. It is said so. So they suggested 3 names, perhaps to, we call it in our colloquial language, to butter Mrs. Indira Gandhi. So they offered 3 names: Aryabhatta, Mitra as a symbol of friendship between Soviet Union and India, and Jawahar, the first name of Jawaharlal Nehru, her father as well as India's Prime Minister. Perhaps they might have thought that adding if she selected Jawahar's name, she will easily give the money. Anyhow, she very easily gave the money and she chose the name Aryabhatta. I remember I was in the college at that time, and when Aryabhatta was launched, the Western newspapers' coverage was India launched spy satellites. There was nothing, no instrument which can spy on other countries in Aryabhatta. There were few, I think there was some solar sun detection or some based some instruments and such a small payloads. Nothing, no video cameras, no radars. Then we continued with the Bhaskara 1 and 2. But at this stage, we take one step ahead because Bhaskara 1 and 2 were the first experimental remote sensing satellite built in India. There were onboard TV cameras. Their imageries were used in the field of hydrology and forestry, etc. Very rich scientific data was sent by Samir. I think it was made in SAC was used for oceanographic studies. Bhaskara 1 and Bhaskara 2 are very much identical, each both differing in mass by only 2 kg. Launched 2 years apart. They have very similar orbit, 590 kilometers perigee, and 541 kilometers apogee for Bhaskara 1, 541 perigee and 557 apogee for Bhaskara 2. Both were more or less 50 and a fraction degree inclination, because that they were also launched from Kapustilia. They had TV cameras and 3-band Samir. Perhaps this is the first step towards our remote sensing satellite series to come later. Then came the Apple Ariane passenger payload experiment. This was ISRO's first indigenous experimental communication satellite, launched into geosynchronous transfer orbit by European Space Agency's Ariane vehicle from Kourou on June 19, 1981. I hope all people can follow because I am speaking in English. ഇന്ത്യയുടെ ആദ്യത്തെ കമ്മ്യൂണിക്കേഷൻ സാറ്റലൈറ്റ് ആയിരുന്നു ആപ്പിൾ. ഇന്ത്യയിൽ നിർമ്മിച്ച ആദ്യത്തെ പരീക്ഷണാടിസ്ഥാനത്തിലുള്ള കമ്മ്യൂണിക്കേഷൻ സാറ്റലൈറ്റ്. ഇതിനെ 1981 ജൂൺ 19 യൂറോപ്യൻ സ്പേസ് ഏജൻസിയുടെ ഏരിയൽ റോക്കറ്റിൽ തെക്കേ അമേരിക്കയിലെ ഗയാന എന്ന് പറയുന്ന രാജ്യത്തെ കോഡ് എന്ന് പറയുന്ന സ്ഥലത്തുള്ള അവരുടെ സ്പേസ് പോർട്ടിൽ നിന്ന് ജിയോ സിൻക്രോണസ് ട്രാൻസ്ഫർ ഓർബിറ്റിലേക്ക് വിക്ഷേപിച്ചു. ജിയോ സിൻക്രോണസ് ട്രാൻസ്ഫർ ഓർബിറ്റ് എന്ന് പറഞ്ഞാൽ ദീർഘവൃത്താകൃതിയിലുള്ള ഒരു ഓർബിറ്റ് ആണ്. പെരിജി ഭൂമിയുടെ വളരെ അടുത്തായിരിക്കും. ഇറ്റ് ക്യാൻ ബി ഈവൻ 300 കിലോമീറ്റർ പ്ലസ് ലൈക്ക് ദാറ്റ്. അപ്പോജി 36,000 കിലോമീറ്റർ അകലെ. ജിയോ സിൻക്രോണസ് ട്രാൻസ്ഫർ ഓർബിറ്റ് ഈസ് എ great what you call very large elliptical orbit with the perigee very near to Earth. Around it can be between 300 and 400 kilometers, and the apogee at 36,000 kilometers. Later, Indian engineers and scientists boosted it to geosynchronous orbit, which is a circular orbit over the equator at 36,000 kilometers. The booster was derived from the 4th stage motor of SLV3. See, that is how the SLV3 development in Trivandrum helped the satellite fabricated in Bangalore, and later the applications moved into the Space Application Center. Now, interesting thing is, I hope we may not come there. How it happened, how the name came also was, the Ariane, European Space Agency's rocket was being tested, and in this third developmental flight in 1981, they had a slot free for a satellite. So they announced that any country who can make a satellite within 2 years, it should be completely done and handed over to them. Then they will launch that satellite free of cost. And ISRO jumped for the offer, made the communication satellite in 2 years' time. It was a very simple satellite. It had 2 solar panels, 2 transponders, C-band transponder, and I believe that one of the transponder was a standby. That's what I remember. And it was a 3-axis stabilized satellite. So we made it in 2 years' time, handed over to ESA, and ESA launched it, and Indian engineers moved it to geosynchronous orbit, geostationary orbit at 1 or 2 degrees east over Indonesia, and beamed the programs to the Indian subcontinent. Now, what we gained by all this thing? One thing is, it gave ISRO valuable hands-on experience in designing and developing a 3-axis stabilized geostationary communication satellite. And second, its orbit tracing maneuvers and orbit deployment of appendages like solar panel and other thing, station keeping of a geostationary satellite, etc. Now, what is the difference between Apple and the Bhaskara 1, 2 and Aryabhatta? Aryabhatta, Bhaskara 1 and 2 were spin stabilized satellites. Spin stabilized satellites rotate about an axis at a rate of about 1 rotation per second in order to keep the satellite stable. Otherwise, there are so many perturbations happening in space, like the Sun's attraction, Earth's own attraction, Jupiter's attraction, many other such disturbances can happen. So we keep the satellite rotating. Now, one difficulty with such a satellite is you cannot deploy openable solar panels for such satellites. That is why Bhaskara and Aryabhatta, Bhaskara 1 and 2 all have 26 sides, and it has solar panels on all sides except the top and bottom. But here in Apple, we had two, it's like our hands, two solar panels, which the engineers could open once it reaches or on the way to the geostationary orbit. This gave us very valuable hands-on experience in all these aspects. So we were learning step by step how to make satellites. Trivandrum people were learning how to make launch vehicles, and others were learning how to control the satellite, keep it stationary in the orbit, how to keep the station, do the station keeping, and all such things. These are going to be very beneficial to us later when our INSAT series, GSAT series satellites are deployed, as well as the IR satellites. Now, what is orbit racing and in-orbit deployment advantages? The elliptical orbit at the center is called the GTO, geosynchronous transfer orbit. All geostationary and geosynchronous satellites are launched into such orbit. Then, when it is at the apogee, we fire the apogee booster motor, ABM, or liquid apogee motor, whatever name we call it. If the fuel is liquid, we call it LAM. Otherwise, it is apogee booster motor for Apple, which was a solid fueled booster. Then on the way to the final slot, engineers started deploying the solar panels and many other things, occasional testing of some of the payloads, etc. Then after many such booster firing and nudging, slowly the satellite is brought into a drift orbit where it is allowed to drift into its final slot. We have 73 degree east, 92 degree east, and 84 degree east, and all such slots available for India. Now, Apple is difference. Bhaskara and Aryabhatta were 47 watts power only it used to generate. But two solar panels, Apple generate 2 watts of power. It was axis stabilized, and for that, momentum wheels, torques, hydrazine-based reaction control systems, small thrusters, and things were used. Programs were communicated or broadcast using C-band transponders. Main thing, it was geosynchronous, geostationary at 102 degrees longitude. So any satellite which is on equator, which is geostationary, the inclination is 0 naturally. This is the Apple utilization program that happened in, I think, in 1982, 83 somewhere. The Apple was at 102 degrees east. Lot of programs were beamed to Apple, experiments were conducted. I think, I remember a few things which we can, I can recollect this video teleconferencing experiment, time division multiple access experiment, etc., etc. Now, we started with Aryabhatta in 75, moved on to Bhaskara 2 in 81, and Apple also 2 in 81. Then this was enough for Indian engineers, ISRO's engineers to learn whatever sufficient learning and move on to very specialized application satellite. So now we have Earth observation or remote sensing satellite. Total 44, and I wrongly put in 48 there. Then we had communication satellites in 2 series, INSAT as well as GSAT, 48 numbers. Then we have a global positioning or navigation satellite, IRNSS, 7 satellites. Of course, we launched 8 because 1 has gone wrong. We have meteorological sats, which are basically Some are communication means geostationary satellites like Kalpana. Then we move to the next higher stage where NASA or USSR or China is there. We move to scientific satellites like AstroSat, the Aditya L1. We had X-ray polarimeter satellite, ExpoSat, etc. We also conducted very successful interplanetary missions. Chandrayaan 1 was an orbiter which functioned very well. Chandrayaan 2 failed, most of you know. And Chandrayaan 3 still was successfully landed on the surface of Moon. We had a Mars orbiter mission which traveled 22.5 million kilometers or something, and crore for 22.5 കോടി കിലോമീറ്റർ ദൂരം പോയിട്ട് മാർസിനെ ചൊവ്വയെ ചുറ്റിത്തിരിഞ്ഞുള്ള മാർസ് ഓർബിറ്റർ മിഷൻ. We will go to some of these. The first in our applied, very dedicated series, application satellite for communication was INSAT 1A, B, C, D, which we got done in the US in Ford Aerospace. Sadly, the family's history is quite bad. I think INSAT 1A failed. In B, you can see an umbrella type solar boom. It couldn't be deployed fully, or rather it took a long time to do that. This was supposed to compensate for the solar pressure on the solar panels. C also has a problem, D also has a problem. So perhaps INSAT 1 series was not something which we can celebrate. But INSAT 2, I think INSAT 2 also one failed, but INSAT 2, 4 satellite, 2 series, INSAT 3 series 4 satellite, and INSAT 4 again 4 satellite. All 12 satellites were designed, made in India, and it worked fantastically more. Almost all of them. And you can see the power has gone to, compared to 47 watt of Aryabhatta and Bhaskara time, it has gone to 4,000 plus watt power generation. Then, 5922 watt generation. Then its mass also has gone from a mere 320 to 360 and 442 to 1,386.55 kg. This I just took one example. There are bigger satellites yet to come. We had nickel hydride batteries for eclipse support, which can store up to 4 to 64 watt power. Its life has also gone. Aryabhatta's life was few days, practical life. Bhaskara 1 and 2 were 1 year, but the INSAT series and later GSAT series life are 7 to 12 and even 15 years. Most of our heavy satellites were launched using Ariane satellites, Ariane rockets. Mainly because we did not have at that time our LVM. Also, LVM's upper limit is 4,000 kilogram, I think. In this series, the last one is GSAT 11, which is the next generation high throughput communication satellite of India, heaviest satellite built by ISRO. It is 5,854 kg, nearly 6-ton weight. It is parked at 74 degrees east. Its power generation is 13.6 kilowatt. They have 32 user beams in the KU band and 8 hub beams. Data rate is 16 gigabits per second and a mission life of 15 years. This is the first 6-ton class satellite of ISRO, made by ISRO, built in India. And the 34th communication satellite built by ISRO. A picture is there on the right side, which is actually on a pedestal. The latest is GSAT N2 is the latest communication satellite in this series. Now we move on to the remote sensing satellite, the other family of satellites made by India. What happens in remote sensing or Earth observation is, yes, observe the Earth. So for observing the Earth, these satellites have either a panchromatic camera or linear imaging self-scanning array, LIS, that's what we call, or sometimes very wide coarse resolution, very coarse, called wide field sensors. They look at the Earth, and when the satellite is passing over the country, not only our country, even other countries, it picks up the images from the path. And that images are converted into imageries and can be used by various people, various departments of our government, hydrology, forestry, fisheries, everybody. Now, what is the difference between Bhaskara, Apple Insat GSAT series and these series? Bhaskara was moving at 50-degree incline to the equator. Insat GSAT series were geostationary satellites. They were on the equator at 36,000 kilometers. It will take 24 hours to go around once around the Earth. The same time taken by Earth to rotate once. So you can have 24 hours communication with the satellites. But polar satellites go over the poles. So in the picture here, it has shown the upward motion because on India, other side it is downward. When these satellites pass over the Earth, they scan a particular belt, we call it ribbon or something like, and pick up the images, which are either transmitted immediately or stored and transmitted later. In the next orbit, the Earth has moved eastwards, so it will be some other country as shown in the picture. It is in the left picture, it is over New York and Florida and other part. And in the second one on the right, it is already moved to the western United States and the Pacific Ocean. So all this information is scanned and either transmitted immediately or stored and transmitted to Earth stations in India. After a certain time, it will come back to the same original path that we call revisit time. I don't remember the data, all the details of these satellites nowadays. Now, you might have heard a lot of names like Megatropic, OceanSat, and etc. All are remote sensing satellite or Earth observing satellite. There are 44 IRS family satellites now. It started with IRS-1A launched from Baikonur Cosmodrome in 1988 using a Vostok rocket, the same cosmodrome from which Sputnik was launched and Yuri Gagarin traveled to space in 1961. Later, we started launching our IRS satellite from using our own satellite rockets, launch vehicles, PSLV, from Satish Dhawan Space Center at Sriharikota. Now, OceanSat is the other name for IRS-P4. There are resource-sat, there are RISAT, that is radar imaging satellite. There are Cartosat used for map making and other applications, IMS series. Then there is Indo-French collaborated Megatropics, another remote sensing satellite, at 827 kilometer altitude and 20-degree inclination. So unlike the other polar satellites, IRS family, Megatropics covers a thick band around the equator, 20-degree inclination only. Then there are Saral, Earth observation, EOS series, now latest one, high seas, etc. Then we go to we have a navigation satellite family, which very colloquial name we call it GPS satellite, because USA's NavStar satellites were called global positioning system. So the GPS essentially means it's a common name for all navigation satellites. But unlike the NavStar satellites is in a constellation of US, or the, I think, Biden, that's what China's constellation is called. Then Galileo is another name used by European Space Agency for the navigation satellites. That's I recollect, I think so. There are multiple satellites, lot of satellites at around 20,000 kilometers in the MEO, middle Earth orbit. But quite different from them. We can't afford so many, what we call dozens of satellites. So we went for a different configuration where we have 4 satellites which are geosynchronous satellites, but they keep moving. They are not geostationary. And we have 3 geostationary orbit satellites at 129 degrees east, then 83 degrees east, and at 32 degrees east. So these 7 satellites together help us for the application of navigation in India, for air, many other applications. IR&SS have a coverage area as shown in the circular orbit. The whatever dotted line in the shape of 8 shows geosynchronous satellites 4, 2 pairs, and the GEO, they are geostationary orbits. Together, they give a wide coverage to circle around India. You can see most of China is covered, up to Saudi Arabia's half is covered, Sri Lanka and far below is covered. And it has an extended coverage area with 20 meter, greater than 20 meter accuracy, even for a larger area. We move on to science satellites. Our first astronomy satellite was AstroSat, the first dedicated Indian astronomy mission. So far, we have seen experimental satellite, then we moving on to application satellite, which are the most essential for our country's development, like IRS, communication satellites and navigation satellites. And now ISRO has moved to, since 2015, to science satellites. AstroSat was the first one. I'm just not reading all the details. It was 1,515 kg weight. It was launched on September 28, 2015 into a 650 kilometer orbit inclined at 6 degrees to the equator. The launch was carried out by PSLV C-30 from Satish Dhawan Space Center, Sriharikota. The minimum useful life was at that time expected to be 5 years. Then we launched the second science mission, rather astronomy mission we call it. It is a solar astronomy satellite, Aditya L1. L1 is a abbreviation for Lagrangian point 1. It is dedicated to the comprehensive study of sun. There are a lot of many other satellites launched by different countries are already studying sun, because our existence depends upon the sun. We are also very keen to know what is happening inside the sun. What are the causes of the coronal mass ejections, the sunspots, the magnetic and solar wind, then how the solar wind and the magnetic storms interact with our own Earth's magnetic field, etc. etc. So it has got 7 distinct payloads developed indigenously, 5 by ISRO and 2 by Indian academic institutes in collaboration with ISRO. I'll just go a bit detail about what are these Lagrangian points and why we go to the Lagrangian point to study sun. Okay, I go back to the last. Now, this is one of the very interesting, what you call, fallout of mathematics. In the 1700s, I feel it was in 1760s, Lagrange, an Italian mathematician who settled in Florence in France, put forward the idea of 3-body problem and perturbation. That is the paper's name. According to that theory, if a small body comes in between or near 2 other massive bodies, it can remain stationary, relatively stationary at 5 points in the system. These 5 points are called Lagrangian points 1, 2, 3, 4, and 5. Now, L3, as you can see, is the opposite side of sun. So you cannot look at L3, anything at L3, and is as of today useless. L4 and L5 are almost 15 crores away from Earth and Sun. So L4, Earth and Sun makes a equilateral triangle, and L1, Earth, Sun, and L5 also makes an equilateral triangle. As on today, we don't use L4 and L5. But in future, when we don't know, we can use it for as a stable locations for space colonies, etc. In the Jupiter system, there are small asteroids caught in L4 and L5. They are called Trojan asteroids. So they move around in these locations along with Jupiter around the Sun. Anyhow, that is an astronomical fact. But here, when we are at L1, the Earth never comes, Earth or even the Moon never come between Sun and ഐ.എസ spacecraft at L1. So the spacecraft can look at Sun 24/7, 365 days. And that is the best point to study Sun. You never miss the Sun. You can see it always and always. So there any mission to study Sun are placed at L1. Now, L2 is a very good point to study the universe because the satellites there look away from the Sun, and Sun's infrared and light do not fall on the satellites. There will be a shield to prevent it. And the Earth never eclipses it. So that's the best place to watch universe, what is happening in the universe, continuously without any interruption. And here there are spacecraft L1 and L2. At L1 there was Discover, I think it is still there, ഐ.എസ, then Wind and SOHO. SOHO is a very, very famous spacecraft of NASA and ഐ.എസ, Solar and Heliospherical Observatory, that is the full form. That is also stationed at L1, and now our Aditya L1 also joins at L1 to watch over the Sun and warn us quickly, because from there to Earth, the messages can come very fast. I think the distance is 15 lakh kilometers between L1 and Earth. Same way, L2 is also 15 lakh kilometers away from Earth on the outside. Now, James Webb Space Telescope is located at L2. Earlier, Gaia, a wonderful spacecraft, space telescope of ഐ.എസ was also there. But Gaia wrapped its last about a month back. There was a news in Science magazine of American AAAS, I forget the full form, that Gaia is no more functioning. In future, suppose ISRO or India wanted to put a observatory to watch things happening in the outer universe, it will definitely go to L2. Now, another important aspect is, from Earth it is 15 lakh kilometers. All other satellites which we launched so far were at the most at 36,000 kilometers. And Bhaskara and IRS and many things were about 600 to 800 or 900 kilometers altitude from Earth. But L1, Aditya L1 is at 15 lakh kilometers away. So, guiding Aditya all the way to L1, putting it in I think it is in a Lysage's orbit, that is a repetitive orbit, which is going around L1, is very complicated. And we could manage it. That is something to be proud of. Then we have planetary missions. We had Chandrayaan-1, India's first mission, an orbiter, successful. Chandrayaan-2 was our second lunar mission, a orbiter, lander, and rover, but it failed, as we know. And Chandrayaan-3 is a repeat of Chandrayaan-2, a orbiter, lander, and rover, and it successfully landed on the Moon, and our rover functioned perfectly. So we are among the 4 countries, along with first USSR. Their first mission landed there on the Moon. That was Luna 9. Then USA, that is NASA. Then now China, and now India has also landed on the Moon. Then we had the very great mission, Mars Orbiter mission, Mangalyaan, which traveled all the way to Mars and entered an orbit of 372 kilometers by 80,000 kilometers. This helps to scan the Martian atmosphere perfectly and send us Very, very, very useful information. Finally, in 2025 or 24 or last 25, we had the SPADEX experiment. SPADEX, in which 2 spacecraft docked inside the space, in space. Now, why dock in space? Why can't you just go there and come back, just like Space Shuttle did or the earliest satellites did? Now, the realm of space research and space travel has greatly changed. We are in a new, totally different, realm, where we have space stations there. Earlier, there was BIR, the wonder of space, they called it, NASA called it, Soviet Union's space station, which is no more there. Now we have ISS, and in the future we may have more. China has Tiangong now in space. India also is dreaming. Of course, our dreams have come so far realistic, and it will also come true, I hope. So we also may have a space station in space. In that case, how do our Gaganauts travel all the way to space and enter the space station and stay there? So we travel in a smaller vehicle, Gaganyaan for India. For Russia, now it is Soyuz, and for USA, now it is Dragon spacecraft of Falcon. They don't have any of NASA's spacecraft now. So these travel all the way to space, then speed up or adjust according to the orbit of International Space Station, dock with it, and once the docking is successful and all checkouts are done, the cosmonauts or astronauts, they cross over to the ISS. They transfer themselves to the ISS, keep the vehicle there for return journey, and then they stay there and do a lot of experiments. In fact, Russia's Salyut 7, Rakesh Sharma traveled to space and stayed there for 7 days. Then in Mir, Dr. Valery Polyakov, one Russian doctor connected with the space missions, lived there for more than 1 year. Then recently, in the last many years, many Russian, other countries, astronauts, European astronauts, French astronauts, even Saudi Arabian astronauts traveled to space, lived in International Space Station for a week to many months, conducted a lot of experiments in which we cannot conduct on Earth, like experiments which can be conducted only in microgravity, then lot of experiments. I am unable to recollect. There was one experiment which Christina Koch and others carried out. That's called Bose. The experiment is related to Bose, S.N. Bose. Bose condensation matter experiment or something like that. So in order to conduct various experiments in space station, we have to travel to space station. So we have to dock with the space station. Then people live there for months. Very old people. Recently, you might have heard of Sunita Williams, who went there in Boeing's Starliner, got held up there for nearly 9 months. She went for 9 days and 9 months she stayed there and finally came back in Dragon spacecraft of SpaceX. So they need food, oxygen, water, dress, then personal items, then messengers, letters, books to read, many things which they send their relatives and other agencies send them. So these are carried by cargo spacecraft. Soviet Union and now Russia's cargo ship is got Progress. Europe has got automatic transfer vehicle. I think Japan has got something called Konturi or something. Then one American company, I don't recollect the name quickly, they have got Cygnus cargo spacecraft. These are carry this material, go dock with the space station, transfer all the materials there, then collect back all garbages, including waste materials, used up dress and other thing, useless equipment, everything. Then de-dock from the ISS, fall into the Earth's atmosphere and burn up. So docking and separation are very much important maneuvers if you want to have SA in space, if you want to make your own space stations and carry out experiments. So it's an extremely complicated maneuver and is usually done automatically, but I think the commander of the arriving ship has also got the ability to take control himself or herself. This is the SpaceX. India sent 2 identical satellites, A and B. They docked in space, then separated, and then redocked. So we traveled 50 years from the tiny Aryabhata to SpaceX. Half a century of dedication and achievements. Now we have 48, we launched 48 communication satellites, and to the best of my knowledge, about 20 plus are working. 44 Earth observation satellites, again 20 plus are working. 7 global position satellites are working. We had 2 astronomical missions, AstroSat and Aditya L1, both were successful. We had 4 interplanetary missions, 3 Chandrayans and 1 Mars orbiter mission. 3 out of the 4, 3 were successful. We had 9 experimental satellites and 18 student satellites. Just a look at the net today told me that India has built and launched 130 satellites. This information is from Indian Space Situational Assessment Report for 2023. So quite a proud journey for India, ISRO and Indian scientists. And we have every right to celebrate Aryabhata's Golden Jubilee celebrations. Those who are interested, especially the students, if you want to know more about space travel and other things, there are innumerable books in English, no doubt. There are 2 books in Malayalam written by me, An Introduction to the Science and Technology of Space Exploration, which I wrote in 2016, published by Kerala Shastra Sahitya Parishad, 400-page book, and A Boundless Space for Children, Adurugalillatta Bahiragasham, in 2019. These books are available in Kerala, and those who can read Malayalam. Thank you very much. And if you have any questions, and I hope some of it I may be able to answer, others I may not be able to answer, but I can tell you where you can find the answers. So thank you very much for joining me and listening to me patiently for this talk.
Hi.
Hi.
I just wonder if there is any queue for asking questions, but I am just jumping in. Thank you for this wonderful talk, and it's really inspiring. We are all proud of what ISRO has achieved so far and looking forward. എനിക്കൊരു സംശയമുള്ളതെന്ന് വെച്ച് കഴിഞ്ഞാൽ ഇതിപ്പോ നമ്മളുടെ ഈ മിഷൻസ് ഒക്കെ ഒരു ഗ്ലോബൽ മിഷൻസ് ആയതുകൊണ്ട് how the hierarchy for permissions look like? What are the agencies that you have to have permission to do such space experiments, and what are the measures that you have to take before you launch a vehicle into the orbit?
Nowadays, there are so many small startups entering the field of space research, and they are making small rockets, satellites, and other things. And in order to coordinate it with the government of India, I think we have in space, an agency which coordinates all these things. So I think, except perhaps, I don't know, even for ISRO, definitely for non-ISRO agencies have to go through in space.
So the InSpace is a global agency or something like that?
So InSpace is the coordinator for Indian space program. They coordinate between the world agencies as well as the startups and others within India.
Oh, that makes sense. Okay. Thank you.
Hi, sir. I think you are audible. So, recently seeing the trajectory which Apple followed, a solid apogee motor have been used multiple times as I understand. maybe I could be wrong. So I'm wondering how it was possible with the limitation of solid engines that it cannot throttle or operate in the start-stop manner.
Pardon? Your question is not very clear to me.
So recently seeing the trajectory that followed by Apple Satellite, so
Okay.
a solid apogee motor was used for orbital rises.
Okay.
So I was wondering how it was made possible with the solid engine, as it has the inability to throttle and operate in a start-stop manner. Like I have in the image, it was showing like it had at least 2 or 3 orbits. So the engine has to be used multiple times. So how it was made possible?
Okay. The first thing is the situation. At that time, India had only solid rockets, like our SLV. SLV is a 4-stage solid fuel rockets. And we did not have any liquid engine rockets. So the idea was to use it. Perhaps I'm not very clear how many times you can fire it, but then it has to be fired multiple times. As we learned, solid boosters are fired, not extinguishable. That means it can be fired only once. That's what we understand. But there may be mechanism to overcome this limitation for that particular apogee booster motor. But later, as you can see for INSAT and GSAT, we have gone to liquid apogee motor, LAM. But it is very easily, you can control the ignition rate, you can switch it off, you can switch it on again. Also, perhaps because I was trying to keep myself within the time limit, later satellites in INSAT and GSAT series used ion thrusters for even the precision correction of positions and station keeping.
Okay, thank you, sir.
Maybe Anurag, I'll find out whether they found how they managed to switch off and reignite a solid booster. I'll pass on to that through LUCA if you can contact this one.
Okay, sir. Actually, I do have your contact also.
Okay, you can. You may be able to get my email and send your email and your questions. If you want, you can note down. My email is sidhupm2012@gmail.com. sidhupm2012@gmail.com. I'm sorry, one student or perhaps somebody has told, sir, please Malayalam. I do understand that. Yesterday also, when Chandrasekhar talked, there were frequent requests for speaking in Malayalam. But how I fell into speaking in English is, I can see many friends from ഐ.എസ്.ആർ.ഒ. who are non-Malayalis or they cannot speak or understand Malayalam. That is why today I spoke in English. Hopefully, in some other talk, we will do it in Malayalam. Tensi Terry has asked, what is the difference between Soviet and Indian space technology? See, space technology is a quite complex and very wide field. How it differs is, we started from scratch, made our initial launch vehicles using solid boosters, solid rockets like SLV and ASLV. Then went into hybrid mode in PSLV. Then again, GSLV is also in a hybrid mode. On the other hand, the Soviet rockets were initially itself liquid fueled, especially they used the liquid oxygen and kerosene. That was also used by Dr. Goddard in USA in the 1930s, as well as Adolf Hitler in V2. Of course, not Adolf Hitler, but Werner von Braun and others in Germany before the Second World War. But they had many other reasons. They could catch hold of German rockets, work on it like that. But India, we did not have any such booty. So we started from the scratch, worked on and developed one by one all these technologies. Second thing is, I won't blame Russia or Soviet Union like that, but India, or rather ISRO, was more focused on applications that our country needs. That is why we had a series of 48 communication satellite and 44 remote sensing satellite, then 7 IRNSS satellites, and then we slowly stepped into scientific applications, interplanetary missions and other things. On the other hand, because of the intense space competition between NASA in USA and at that time USSR, later Russia's agency is now called Roscosmos, they were keen to develop missiles or rockets, then satellites. There was an intense competition. Then how to land people on moon. We never dreamed of landing people on moon using our taxpayers' money, etc., etc. Then, of course, they had a lot of interplanetary missions. India did not jump into such a bandwagon. We focused more on our applications and needs. Now we are capable of thinking in a bigger scale. So we thought of landing our vehicle in moon, then sending one to Mars, then launching 2 astronomy satellites, etc. That is how that's a basic, some different elementary difference I can say. Jinsey Thomas has asked what is GEO, GSO, and sun synchronous orbit. Yeah, I'll just briefly go through because okay, GEO means geostationary orbit. That is, GEO is the short name for that actually. That is an orbit at 36,000 kilometers above equator. At that altitude, that's a satellite placed at that altitude will take 24 hours to go once around the Earth. The Earth also takes this equal time to rotate once. So the advantage of that orbit is you can communicate with that satellite 24 hours, 365 days. That is geostationary orbit, but it's a very rare orbit. There is a lot of competition for placing there. Of course, so far the logic was those who have the power, they placed their satellites there. Then geosynchronous orbit takes 24 hours to go around the Earth once, but that is not placed on equator. It has a slight inclination. So it will, just like we say sunsets and sunrise, these satellites will set and rise, but it is not very frequent. But at a long duration, they will set and rise. Sun synchronous orbit is an orbit on the poles, going around the poles. But this orbit, if it is sun, it's a polar, generalized term is polar orbit. Sun synchronous orbit crosses a particular place always at their local time. Say, perhaps we are speaking, imagine Trivandrum. A sun synchronous IRS satellite might have crossed Trivandrum on a particular day at 8 a.m. The next time, when it is the revisit time to go over Trivandrum, maybe after 12 days, 18 days, or whatever it is, again it will fly over Trivandrum at 8 a.m. that day. That is sun synchronous orbit. These such sun synchronous orbits are necessary, especially for agricultural applications. You see, if you take a photograph of a paddy field or other thing, one day at 8 o'clock and then another day at 4 p.m. and other thing, it won't work. So you need to a sun synchronous orbit for such applications. Then ADW has asked one question: why does the inclination matter? Inclination is the orbit's slope. You know that the orbit is inclined around the equator. If the inclination becomes 0, it becomes geostationary orbit. If it's at that height, 36,000 kilometers. If it is inclination is high, 90 plus or 90 plus minus, then it is polar orbit. So it will go around the poles. Inclination matter because most of the satellites, many of the remote sensing satellites, want to observe Earth for a particular application. But inclination need not be 90 degree always. For example, megatropics have 20 degree. So if you look at the the path of megatropics around the equator, it is like a band. It is like a bunch of bangles just at the equator. INSAT is basically INSAT and GSAT series are GEO, not GSO. And 3 satellites of IRNSS is also GEO and 4 are GSO. Yes.
Sir, എന്റെ പേര് അനശ്വർ ദേവാണ്. ഞാൻ 4ാം ക്ലാസ്സിൽ പഠിക്കുകയാണ്. എനിക്ക് സ്പേസ് നല്ല ഇഷ്ടമാണ്. ഞാൻ സ്പേസിന്റെ വീഡിയോ എല്ലാം കാണാറുണ്ട്. അതുകൊണ്ടാണ് ഞാൻ ഈ മീറ്റിംഗ് അറ്റൻഡ് ചെയ്തത്. അപ്പൊ സാർ ഇംഗ്ലീഷിലാണ് സംസാരിച്ചോണ്ട് മനസ്സിലായി, പക്ഷെ കുറച്ചേ മനസ്സിലായുള്ളൂ. അതുകൊണ്ട് ഇനി ഇങ്ങനത്തെ പരിപാടി വരുമ്പോഴേ മലയാളത്തിൽ കൂടെ ഒന്ന് സംസാരിക്കണേ.
ഓക്കെ, അടുത്ത പ്രാവശ്യം വരുമ്പോ മലയാളത്തിൽ സംസാരിക്കാം. നമ്മൾ പൊതുവെ ഈ എല്ലാ പരിപാടിയും കേരളത്തിൽ ഞങ്ങൾ ലൂക്കയും KSSB ഒക്കെ മലയാളത്തിലാണ് പറയാറ്. പക്ഷെ ഇന്ന് എന്ത് പറ്റി വെച്ചാൽ ഇത് ഇന്ന് ആര്യഭട്ടയുടെ ഗോൾഡൻ ജൂബിലി സെലിബ്രേഷനുമായി ബന്ധപ്പെട്ടായതുകൊണ്ട് മലയാളം കേട്ടാൽ മനസ്സിലാവാത്ത ധാരാളം സുഹൃത്തുക്കൾ ഇവിടെ ഉണ്ട്. സോ അവർക്ക് കൂടി മനസ്സിലാവണ്ടേ എന്ന് വെച്ചിട്ടാണ് ഞാൻ ഇംഗ്ലീഷിൽ പറഞ്ഞു പോയത് കേട്ടോ നീതു. സോ അടുത്ത ടോക്ക് നമുക്ക് ഭാവിയിൽ മലയാളത്തിൽ പറയാം. നീതുവിന്റെ സ്പേസിനെ കുറിച്ചുള്ള ഇൻട്രസ്റ്റിൽ വളരെ സന്തോഷമുണ്ട്. അപ്പൊ നീതു ഇപ്പോഴും നല്ലോണം വീഡിയോ ഒക്കെ കണ്ടോളൂ, പക്ഷെ നന്നായി പഠിക്കണം. പഠിച്ച് ഒരു ഗ്രാജുവേഷൻ ലെവലിൽ എത്തുന്നത് വരെ എല്ലാം നന്നായി പഠിക്കണം. പിന്നെ മാത്രമേ സ്പേസിലേക്കോ ആസ്ട്രോണമിയിലേക്കോ ഒക്കെ തിരിയാൻ പാടുള്ളൂ കേട്ടോ.
ഓക്കെ, താങ്ക് യു സാർ.
ഓക്കെ, മനോജ് ചോദിച്ചിരിക്കുന്നത്, ഈസ് ഇസ്രോ ബിക്കമിങ് എ കമേഴ്ഷ്യൽ ഓർഗനൈസേഷൻ ദാൻ എ സയന്റിഫിക് റിസർച്ച് ഇൻസ്റ്റിറ്റ്യൂഷൻ നൗഡേസ്? Okay, my friend Manoj K. Pudiyavada has asked a question. Is ISRO becoming a commercial organization than a scientific research institution nowadays? മനോജിന് എന്തുകൊണ്ടാണ് അത് തോന്നിയെന്ന് അറിയില്ല. കാരണം ഇപ്പോഴും ഇസ്രോയുടെ മേജർ പ്രോഗ്രാംസ് ഒക്കെ തന്നെ നമ്മുടെ രാജ്യത്തിന്റെ ആവശ്യങ്ങൾക്ക് വേണ്ടിയുള്ള ആപ്ലിക്കേഷൻ സാറ്റലൈറ്റ്സും സയന്റിഫിക് എക്സ്പ്ലോറേഷൻ എന്നീ മേഖലകളിൽ തന്നെയാണ്. പക്ഷേ we are spending nearly 6,000 crore plus every year. So if we have some free slots in our launch vehicles, no harm in accommodating foreign satellites and earning some foreign money. അതാണോ മനോജ് ഉദ്ദേശിച്ചതെന്ന് എനിക്കറിയില്ല. പക്ഷേ നമ്മുടെ SLVയിലും GSLVയിലൊക്കെ സ്ലോട്ട്സ് ഫ്രീ ഉണ്ടെങ്കിൽ നമ്മൾ മറ്റുള്ളവരുടെ സാറ്റലൈറ്റ്സിനെ കാശ് വാങ്ങി വിക്ഷേപിക്കുന്നു, അത്രയേ ഉള്ളൂ. നമ്മുടെ ഒരു വാഹനം കണ്ണൂരിൽ നിന്ന് തിരുവനന്തപുരത്തേക്ക് ഫ്രീ പോകുന്ന ഒരു സീറ്റ് ഒഴിവുണ്ടെങ്കിൽ ആരോടെങ്കിലും കയറി ഇരുന്നോളൂ, കുറച്ച് കാശ് തന്നാൽ സന്തോഷം എന്ന് പറയുന്നു, അത്രയേ ഉള്ളൂ എന്നാണ് എനിക്ക് തോന്നുന്നത്. ഇസ്രോ ഹാസ് നോട്ട് ഗോൺ ഫോർ എനി full scale commercial application. In fact, ISRO is trying to not to do that because we wanted even private companies or others to take the know-how of PSLV and other launch vehicles and manufacture launch vehicles. We wanted the same for satellites so that ISRO's energy can be concentrated, focused on our science missions and other things.
Hello. Can you hear me? Yeah.
Yeah, I can hear you.
Manoj, Mr. Sidharthan, can I add a few words?
Okay.
Manoj, ISRO is now more interested in doing more and more R&D. So whatever we have developed within ISRO, we want to give it to industries and let them do it using our own facilities inside our ISRO. So many of the industries, more than 100 industries, are using our facilities and developing satellites, rockets, everything. So that is our interest in ISRO. We want to concentrate more on R&D and develop new technology, hand over to industry to redo it and carry on. It is a trend everywhere, all over the world. NASA develops and the private party takes over. So that is the trend in ISRO now. Okay?
ഇനിയും നമുക്കിത് കണ്ടിന്യൂ ചെയ്യാം. കാരണം സ്പേസ് എന്ന് പറഞ്ഞാൽ എല്ലാവരുടെയും ഒരു ഇഷ്ട വിഷയമാണ്. ലൂക്കയിലും ധാരാളം ലേഖനങ്ങൾ വന്നിട്ടുണ്ട്, പരിഷത്തും പുസ്തകങ്ങൾ പ്രസിദ്ധീകരിച്ചിട്ടുണ്ട്. സിദ്ധാർത്ഥ് സാറൊക്കെ ഇവിടെ തന്നെയുണ്ട്. അതുകൊണ്ട് നമുക്ക് ഇനിയും ചർച്ചകളും ഇത്തരം പോയിന്റ്സ് എല്ലാം ഡിസ്കസ് ചെയ്യേണ്ടതുമാണ്. അത് മറ്റു സന്ദർഭത്തിലാവാം. അപ്പോൾ ഇത്രയും നേരം സംസാരിച്ച സിദ്ധാർത്ഥ് സാറിന് ലൂക്കയുടെ പേരിലും ഇവിടെ ഉണ്ടായിരുന്ന എല്ലാവരുടെയും പേരിലും നന്ദി പറയുന്നു.